Okay. Hello, everyone. My name is Denise Joswiak, and I'd like to welcome you to the January 21st, 2026 monthly webinar with the Alliance of International Aromatherapists. This webinar is number 239. Tonight's webinar is a collaboration with the AIA Research Academy. Dr. Bruce Boynton and I are co-chairs of the Research Academy, and I see Carol here too. She's part of our steering committee. Yep. And so tonight, Dr. Boynton will discuss how to make tables, graphs, and figures for scientific presentation. Dr. Boynton has a distinguished career as a clinician, researcher, and administrator, and has published over 100 research studies. He is especially interested in assisting young researchers and writers. And as the presentation goes on, we'll probably talk a little bit more about a few of the resources through the Research Academy. But for now, take it away, Bruce.
Okay, thanks, Denise. This is one of my favorite topics, graphs, figures, tables, because they're often done so badly, and I want to teach y'all to do them right. And it's not hard, but there's some things that you have to know. And I'm going to show some good graphs and some bad graphs. And the other thing I want you to do is to understand how to critique graphs, that see the tricks that unscrupulous people have used to distort data. And I think by doing that, by learning how to critique graphs, you will be less likely to make those same mistakes. And when I come to a slide that I want y'all to analyze and tell what's wrong with it, I want to hear from you. Whether it's the right answer, the wrong answer, and I'm going to give you three simple things to look at, and that will orient you to most of the graphs. So let's get started. Okay, how do we make tables, graphs, and figures? And it's very simple: to present data in a clear and succinct way that can be quickly grasped. That's the only reason that they're there. To present data in a clear, succinct way that can be quickly grasped. Unfortunately, many tables, graphs, and figures are: one, unnecessary; two, are needlessly complex and confusing; and three, slant the data for their own purposes. So those are the three questions that we're going to ask about tables, graphs, and figures. Are they necessary or unnecessary? Are they simple or complex and confusing? Do they present data in an objective, honest way? Okay, how to lie with figures and graphs. If they're unnecessary, they present a lot of data. And sometimes you see figures and graphs that they present minimal data, even only one or two observations. Well, it's much better to just say that in the text. If 10% of a group can swim, just say that. You don't have to have a graph to do it. What happens if you only present limited data? It overemphasizes the importance of those data, and we'll see some examples of that. Okay, complex and confusing. If you can't tell what's going on in 10 seconds, the chart is overly complex. The other way that people make it complex and confusing is to use 3D graphics. That is, almost all graphs can be shown in 2D, which is like a plane, like a graph. If they start putting 3D graphs in, what is that other dimension? What does it mean? How to slant the data. here's one thing I want you to look for. Either they omit or truncate the y-axis. Truncate means to cut off the bottom. So it doesn't start with 0, it starts with 10 or something like that. The other thing is to use pictures, which are 2D, because a picture has a height and a breadth instead of bars on a regular graph. And we'll see some examples of that and how ridiculous that is. Why do authors do this? I've got two theories. One, their aim is not to present their data objectively, but to advance their narrative, whether it's a political narrative or an economic, religious, or even scientific one. And so the purpose that they use for the graph is to advance their narrative, not to objectively present the data. The second thing is, and I was going to see if Emily, our graphics designer, reacted to it, but she didn't. Graphic designers are to blame for all the poor graphs. Well, what graphics designers are interested in making colorful, attractive pictures. And they're not trained to present data objectively. So if the scientist gives the data to a graphics designer and it makes a pretty picture, he's happy. Well, he shouldn't be. Okay, here is an example of a table. You see at the top, there's the table number. This should be actually in bold. And then the title of the table is written in italics. Then there are subheadings, which are separated by bars. And then the data, which is all aligned. And if you have to use abbreviations or have some further explanation of the data, you put a note below this. We're going to see another example of this. Okay, this is from the APA handbook. You see the table number is in bold. Now, some people have a hard time. If you only have one table, should you call it table 1 or just table? I don't care. Other editors are fine with table 1, even if you have only one table. Then you need a succinct and explanatory title for your table, and that goes in italics. And you see they have separated the subheadings with 2 bars, and you could even break it down. Here's girls are categories as with or without, boys without, with or without, and they have a single line here. Then there's another line that separates your subtitles from your data. You can have more than one table of data. And then there's a note underneath which explains abbreviations or anything, the origin of the table or the data or whatever. Okay, this is just a summary. For data tables, the table number is in bold. The title is in italics. There should be column headings. Make sure you align your columns, and then a note to explain abbreviations, etc. Okay, one of the things you can do in a large table to assist the reader is to shade alternate rows. Now, you see all sorts of different shades of gray. That's just an example of what you can do. But you should use the same shade of gray on alternate rows, like here, 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 and so forth. And that will lead the reader's eye and be able to grasp your graph more quickly. Okay, how to make a table with PowerPoint. This is a screenshot of my, when I was doing this PowerPoint. You can see I'm making slides right here, and I'm on home. And what you want to do to make a table is go to insert. So you're regularly on home and you're going to go to insert. And I have a slide of that. I've blown this up so you can see more clearly. This is the top ribbon. Here's home. And we clicked insert, and this little table showed up. Okay, we're going to pull this down. And look, a table appears, or blocks that could make a table. And there's 7 columns and 6 rows. And you can also insert a table, get a table from Excel, draw a table. And now what we're going to do is click. You have to figure out how many columns and how many rows you have in your table, and click that. And a box shows up where you can enter data. Now, if you notice, one of these rows is deeply colored. That's for the title. So I have 7 columns, or excuse me, 5 columns, 1, 2, 3, 4, 5. But I only have for data 3 rows, 1, 2, 3, 4. And that's because the 4th row is going to be for the title. So you have to add 1 more row than rows of data that you have. That's how to make a table. And here I've just entered some essential oils and made up some numbers and put volunteer 1, 2. These numbers mean nothing, but this is just how to do the table. Okay, now you can find our journal, Aromatics in Action, uses APA 7 style. And this is a place that you can click and find out information about APA 7. There's also lots of YouTube videos. I just put 3 titles here. If you copy these and go into YouTube, you can watch the videos: creating table tables for your experiment, making data tables for a science experiment tutorial, and creating a data table. All right, this has been adjudged the best table in the history of science. In fact, Mendeleev, who's a Russian scientist who made this table, got the Nobel Prize for it. So if you make good tables, you don't know where it can take you. First, this table has a lot of information. It's got the name of the element, the symbol, the atomic mass, the number, all sorts of good stuff. But you don't get lost because he's color-coded it. So you can grasp it very quickly. On this side, besides hydrogen, are the very, very active metals. For instance, some of these metals, like lithium and maybe sodium, will, if they're exposed to air, they'll catch on fire because they're that active. They combined with the oxygen. Over here on the far right, you see the noble gases that don't readily combine with any other element. Next to them is the halogens, the gases, and here are the nonmetals. Wow, so that means most of the elements are actually metals. And carbon, nitrogen, oxygen, phosphorus, sulfur, that pretty much, those are the elements in life. So of all these elements, we just use a few of them in living creatures. Now, there are always things like iron that's carried by hemoglobin, but mostly it's carbon, nitrogen, oxygen compounds. So good table. Now I'm going to show you a bad one. Look at this. Don't worry about just all the numbers and what they mean. I'm going to point out one thing here. They're talking about standard eras, like your era bars. Standard eras are made from, era bars, confidence intervals are made from standard eras. Standard eras are made from the standard deviation, not the variance. So they shouldn't have variance in here. They should have standard deviation. Now look at the length of the numbers. Some of these numbers went on for 6 digits. 1, 2, 3, 4, 5, 6. That's a millionth. Does anyone care about that? And they didn't have different lengths of the different numbers. You're never supposed to have that. It should be all aligned like in these confidence intervals. So they've dropped the trailing zeros even when they were important, and they have their numerals stretch way too long. So this is not a good table. What about this? Is this a good table? No, it's a worksheet. It does not summarize data. Now, you could have a graph of how many males, how many females, what their age were, where they lived, or whatever. But this is just a worksheet. It's not a table. Now we're going to go on to figures. Same 3 questions. Is it needed? Is it necessary? Is it simple? Or does it slant the data? Now we're going to look at some good and bad figures. This is a good figure. This is from the APA journal. Again, the figure number is in bold. The figure title is in italics, and they have a note. So it's the same format. Okay, here's a useful table. Sometimes it's hard to tell if you have a flu or cold or coronavirus. So this is something that is clear, even though what your cough and fatigue means may not be clear. It's easy to understand, and it's useful. Here's a good figure, and this comes in several parts. What they've done is measured what a certain amount of radiation will do to you if you receive it. And then they're going to have some graphs of how the wind on a particular day blows radioactive fallout across the United States. Now, look at this scale. Is there anything that anyone can see that's wrong with that? Well, let me help you here. How much do you have to multiply for this number to get to this number? Well, 10 times will make 0.01, so 15 times. How many times do you have to multiply this number to get to this number? Well, it's 2. From this number to this number, 5. From this number to this number, 2, 2, 2, 2, 3, 3 and a fraction. So this is a little bit confusing in that they could have used a different kind of graph to show this. But this is a pretty effective graph. And look at this. This is if you dropped, I don't know, I suppose these are, you dropped a bomb here and here and here and here. What would the winds on October 29th, 2021 do to that fallout? Well, they project it in ways that we can't predict. So each of these graphs is completely different depending on what the winds were doing that day. Now, a photograph can be a figure. What does this mean? This is the Marines in the Battle of Iwo Jima raising the American flag on Mount Suribachi. What does this mean? This was Joe Rosenthal in 1944 or 1945 won the Pulitzer Prize for this image, and it's so perfect that people thought it was faked. It's 5 men. There's a guy behind this person, right? You can see him, part of him right here. 5 men who are faceless and are all absorbed into doing a single task, raising the flag. Here's another iconic photograph. This is taken by Ed Anders, one of the astronauts, and it shows our Earthrise from the moon. And what is the story here? How fragile and how different our planet is from every planet, every moon in the solar system. In fact, we don't know of any exoplanet just like that. So Earth is a very special place. It's very fragile. We need to take care of it. Okay, here's another figure. What do you think of this one? Does anyone understand it? I don't.
Confusing.
Yes. What is this? These aren't words. I don't know what they are. And coming out of boxes, it makes no sense at all. Okay. What about this one? This is one for y'all. Is it necessary? Well, yeah, I guess so. Well, but it's only one fact. Maybe they should have just said that in text. Is it confusing? No. Does it slant the data? What do you think? Okay, is this, I guess this is supposed to be 75%, and this is 25%. They've altered the graph for effect. Because if you made it like this, it wouldn't look as impressive. So they just made it smaller. This is an example of slanting the data. What about this one? Carol, you keyed in on this one? I think it's about the brain.
Yeah, it is, but what a mess.
I guess it's some sort of cellular connections between maybe the spinal cord and the brain, or I don't know. What are all these numbers mean? This is way too confusing. It may be necessary. It may not slant the data, but I don't know what it means. Okay, what about this? Any problem with this one? Well, for one thing, there's no one that took pictures. So there's no chance that these mountains on Pluto, Vesta, which is an asteroid, or Iapetus, which is a moon of, I don't know, Saturn or something. And this is on Mars. There's no chance that they look like this. No one has stood on these planets and asteroids and taken this picture. This is fantasy. What they have to do is take satellite photographs and guesstimate the height by the shadows. Okay, the other thing is, why are Olympus Mons and Rio Silva Peak linked here? What do they have in common? I have no idea. And none of the other ones are. Then the Montes Lupus, that's the wrong name for this peak. And then the other thing is apparently 72,000 feet is only a fraction of 75,400 feet. Not only that, but 72,000 feet in the Olympus Mons is much less than 65,000 feet, or much less than 39,000 feet. So they're not to scale at all. So this is a very bad graph. As some says, this doesn't even attempt to make sense. Okay, now I want y'all to weigh in on this one. First, is it necessary? How many pieces of data are there?
Just one.
Right, exactly. Does he slant the data?
Yeah, because there's only 1% difference, but it looks like there's so much more.
Exactly. 46% appears to be half of 47%. What about the pictures? There's a big President Trump with his fists clenched and looking satisfied, and then there's this confused picture of Biden that's really little. So what's going on here? Well, politicians, their job is not to present data in an objective, honest way. Their job is to get votes, and that's what he's doing. This is a masterpiece, though. Okay, graphs. Is the graph needed? Is it clear? Does the graph slant the data? Okay, this is the APA format. Once again, the figure number is in, well, figure or graph is in bold. The title explains the graph and is in italics. There's both a y-axis, if you have a graph like this, both the y-axis and the x-axis, they're labeled and they're segmented into units that we can appreciate. And then they have a note at the bottom. All right, you can make graphs in Excel. It's very easy. I'm on the blank page of Excel, and I just made up these numbers: lavandine, spike lavender, true lavender, and I just put some numbers in and added it all up. And then I summarized it here. And then what I did was I highlighted this by doing this kind of motion till it was all highlighted. And then you go from to insert, and there's a graphics panel, and I just hit bar graphs, and it made this graph. It takes about 15 seconds. Very easy to make simple graphs. Okay, this by authorities, this claims to be the best graph of all time. And it was made by a French engineer after the fall of Napoleon. And what it shows is this width here is the size of the Imperial Army. And they marched from this town in Lithuania all the way up to Moscow. And then that's the tan line. And then the black line is them coming back. And you see that this Russian campaign just decimated Napoleon's army. There was only a fraction of the people who got back. It also shows where they went. These are the rivers that they crossed and how many people that they had there. And it also shows the temperature at that time. So it's a great graph. Contains 6 pieces of information in a 2-dimensional image. How many troops Napoleon had, how they decreased over time, how far he traveled, the temperature, the latitude and longitude of his travels, what direction he traveled, and where the army was when specific occurrences happened. Great graph. Now let's see some that are less good. Any problem here? Y'all happy with this? Come on. Okay, when I saw this first, I said, there's no data, but that's not true. Where's the data?
Oh, it's all on the, is that the X? It's at the bottom.
The X-axis, exactly. So is this graph needed? No. You just say it's whatever this scale is, it's all at 0. And you can avoid this graph completely. Okay, Christianity is dying out in the Americas. And here's Tucker Carlson to tell you that. Anything wrong with this? It looks like less than half of the people in 2009 who said they were Christians are Christian now. Do you believe that?
Yeah, because they didn't start at 0. They started at 58%.
Exactly. They truncated the y-axis to exaggerate the proportions. I'll show you a graph, an honest graph of the same data. It's less impressive. There's 2 other things here too. How many people did they interview? 1,000, 100, 10? I don't know. The other thing is they only looked at 2 points. It would be more convincing if they look at 2014, 2015, and if you see a trend going down, just 2 points, that's a straight line. Truncated y-axis exaggerates the difference. Only 2 years sampled, 2009, 2019. How many Americans were sampled? Well, this is the honest data. It looks less impressive. Okay, anything wrong here? This is one of my favorites. This is about copper prices that were affected by the coronavirus epidemic. And this goes from the 2nd of January to the 23rd of March. This is just fine, right?
Why is, no, the 868 is, why is that going up and down?
Oh, you're right. You nailed it. You nailed it. What is it going up and down? It's all the same. One critic had a humorous analysis of this. We will always remember the copper price crisis of March 2020, when the price fell from $868 on March 18th, first to $868 on March 19th. And after a small rise to $868 on March 20th, it dropped freely towards $868 on March 23rd. So this is just nonsense. If they made, I think they thought if they made a straight line, it wouldn't be as impressive. Okay, unemployment drops, yay. Oh, wait a second. What did they do here? They flipped the y-axis. So unemployment, which was trending up slowly, is about 4.5%. And then it fell all the way to 15% and then rose to 10%. Yeah, I mean, this is just flipping the y-axis is considered a rogue move. Here's something similar. See if you can get this one. Gun deaths in Florida. The great effect of the 2005 Florida enacted Stand Your Ground law.
Yeah, it should be, 0 should be at the bottom.
Right. So when 2005, after Florida enacted its Stand Your Ground law, gun deaths fell from about 725 all the way to 815, and then rose. I mean, it's just this is just utter nonsense. Okay, what about this one? Is this clear?
It's deceptive and unclear.
I don't know what this is. What is this shape?
And numbers are certainly out of order.
and what they're all on here or here. So these guys didn't get any. What? This makes absolutely no sense at all. Okay, what's going on here? Is this honest?
Very tall women in Latvia.
And big.
But it's only 5 inches from India.
Exactly. They truncated the y-axis at about, I don't know, what is this, 4.5 feet or something like that. The second thing is they're using figures rather than bars. Now, see, these figures have a height and they have a width. If we stretch them out, they look stupid. And so it overemphasizes the difference between this tiny Indian woman and this enormous Latvian woman. In fact, an Indian woman had a comment on this graph. She said, I realized when I looked at this graph that all I'd been doing my whole life is just hiding behind a rock and trying to avoid the giants from Australia, Scotland, and Peru, and especially their general from Latvia. So just use bars, don't use figures. Here's the same thing. First, they truncated the y-axis, so it only goes, this is only 5 inches. So to make it more impressive, they had to actually figure. And so this is only a little, 1, 2, 3 inches, 3 inches shorter, not 3 times shorter. Okay, this is a good one too. Got an X and Y axis, bars. This has got to be good. This is a little bit more subtle.
The it's not correct in the, so like the last dark blue bar 1250 is higher than the first light blue bar 23,000.
Oh, good. I didn't pick up on that. That's good. Excellent. See, what they do is they don't demarcate in units the y-axis. That allows you to stretch it and do all sorts of stuff. So it looks like 460. That's about, I guess that's about 3 times 1250. No, that makes sense. But if you go across, 460 appears to be 50% of 4,300, and 4,300 appears to be 50% of 23,400, and 1,250 is greater than 50% of 11,600, and 11,600 is about 50% of 66,000. So they did this because they did not use a real y-axis. Oh, this is a good one.
There are no numbers.
Right. Yes. They don't. They don't have a y-axis, a real y-axis or an x-axis. Yeah, that's quite true. There's some other problems too. Let me ask you, what is this dimension here? You see, you have a line coming out here. This must convey some information. No, they just did it because they thought it looked more interesting. Then there's a second problem, and that's that the laws of perspective, as you get distant, it goes smaller and smaller, regardless of the size of the figure. So you could have if you kept extending it, you could have a very tiny block here that was just as high as these. So they shouldn't have used 3 dimensions when they didn't have a third dimension, and they shouldn't have done it in perspective. Oh, this is pretty easy. I wonder if this was actually submitted to anyone. I mean, they have so many categories in here that the lettering all runs together. They should have used a bar graph and not a pie chart. Pie charts are problematic. I don't like them that much, although there's people that do. And I think that they are appropriate for some kinds of data. But tipping them on their side is never a good idea because it distorts the area. And what is this dimension here anyhow? They just put it in to look good. Here's an example. You see, this is a pie chart that is accurate, but you can see if you tip it on its side, it over up. Well, it overemphasizes this one, and it underemphasizes this one. So it slants the data. And look at this. This is really a gem. It purports to be a pie graph, I guess. It's not only on its edge. Where is the edge? Is this the edge here? Then it looks like an uneven cookie. And what is this? What does this mean? And this mean? And this mean? This is totally incomprehensible. World's most accurate pie chart. Pie I have eaten and pie I have not eaten. What about this? This was this tried to link, I guess, people who were running for, I don't know, the House of Commons in the UK, and see what issues were important to them. So it's a linkage of candidates and issues. I think this is one where the investigator just gave the data to a graphics designer and told her to make a nice picture. You can't tell anything about this. Look at all this complexity in here. Anyhow, don't do that. Here's a good one. Great epidemics represented by sponges. Well, this is the same as picture, only you're looking at volume, and they tell you that the volume, our eyes and brains are best at comparing lengths, less good at comparing areas, and terrible at comparing volumes. All we know is this is really big. These are pretty sizable. These are small. Then they have all sorts of stuff. 11,000 died of Ebola. I thought they didn't have a figure. It's this tiny dot here. And then these are sponges. This is just, it's sort of an interesting idea, but I wouldn't do something like that. Okay. Correlation versus causation. These are some simple bar graphs. And this was done by, these guys must be humorous. The Adolum Australian Laboratories for Puerile Research. Puerile research is childish research. And it shows here that global warming is going on. That's not good, but at least it's bringing down the number of pirates. Well, these things have nothing to do with each other. The other thing is piracy and global warming is on the same scale. Which doesn't make any sense at all. All right, here's another example. If we just sold less ice cream, then we decrease shark attacks. Well, they obviously have nothing to do. So correlation, even perfect correlation, does not mean causation. Let me give you an example. You have two clocks. When one clock strikes 12, the other clock bongs. Did the first clock cause the second clock to bong? No, they're both related to its noon. So that's an example of correlation, actually perfect correlation, but not causation. Okay, this has the honor of, by several authorities, of being the worst graph of all time. People on the internet have studied this and can't decide what it's about. I've looked at it for hours and I can't decide. I offer it to you. What does this graph mean? I think it has something to do with planets, because Uranus and Neptune are here, and Venus and Earth are here, but they've run the lettering together. And then it has all these strange things: 100% iron, 33% iron, 50% water, 100% iron, 2% hydrogen. But then these are 300K. A K stands for Kelvin, which is a way of measuring temperature. 300K, 500K, 700K, 1000K. What it's somehow seems to combine the composition of different planets, their temperature, and then I don't know what these histograms and stuff are. Really, really remarkable, but a pretty picture. Okay, what we've covered. Tables, figures, and graphs are presented to make a clear and succinct way to easily grasp data. Unfortunately, some articles include graphs and tables and figures that are unnecessary, needless, confusing, or slanted data. It's important to follow your journal style guide exactly. So I'll read it several times to make sure I use the right font, use the right format, et cetera, et cetera. Learn to critique tables, figures, and graphs. It'll make you a better author, and you won't fall prey to their unfortunate mistakes. There's good articles on, and in fact, some good pictures of bad graphs on these bad graphs, bad bar graphs, figures and charts, graphical excellence. Okay, what I recommend for you to do, you can find on the internet fairly easily how to cite references or how to format pictures or graphs. I bought the 7th edition of the Concise Guide to APA Style, and I bought the loose leaf version so I can lay it flat on my desk and I don't have to weigh it down by books or anything like that. And just for ready reference, and it's not that expensive. Okay, once again, this is probably 75 years old. I see it was reviewed by Bill Gates. This How to Lie with Statistics. It's a wonderful, humorous, and well-written, not by a scientist, by a journalist, I think, with illustrations. It has how to distort graphs, why everyone makes less than the average wage. Even it goes into misleading or inaccurate headlines. For instance, the San Diego Union had a headline: half of our students are below the median. That's the definition of median. So half of geniuses are below the median. Half of gold medalists in the Olympics are below the median. That's just the definition. Doesn't mean bad. This is probably the most authoritative general guide by Edward visual display of quantitative information. I see it's out in the second edition. I've got the first edition. It's lots of examples, and it is the probably considered the Bible for how to do good graphics work. Finally, how to lie with charts. This is an in-depth, thick book, but it walks you every step of the way through. And we are proud to be the Research Academy for AIA. And what questions do you have?
1 second, Bruce. Before Bruce answers your questions, I just put in the chat, we have a short 4-question evaluation. This is something new. It'll really help us understand how we did and what you want in the future. So if you wouldn't mind just clicking on that before you leave, and now Bruce can answer questions.
Okay.
Feel free to unmute yourself and, turn on your video if you want, and then you can just ask. If you put it in the chat, I'll read it to him.
I just want to thank you because I just can't believe, that, I mean, I just obviously assumed if something was like published or it was in something that it would be accurate, but yeah, I'm just really, really surprised. And thank you so much. I really enjoyed this class. I don't know if you teach anything else, but it was really, really great. Thank you.
Oh, thank you. Yeah, if you go to some of those links of bad graphs and stuff like that, or just put worst scientific graphs in your search bar, it'll bring up all sorts of stuff, and a lot of them are just hilarious. It's really good entertainment.
Christina, there are also other talks that Bruce has done on the AIA website in the Research Academy, and there's lots of really great information that has been presented by him and others. So that's another resource for you. And then also the ones that are posted out on the YouTube channel, the AIA Research Academy YouTube channel. I don't know if Denise has access, can pop that one into the chat. That would be great. Those are another source of looking at some of the things that we've presented.
Yeah, Carol, do you have any idea how many there are up there now? It must be close to 20.
Oh, I haven't counted them in a while, but there's some really awesome presentations that are very, very useful.
Yeah, everything, how to make a poster, how to do a case study, how to do basic statistics, how to analyze a test, all sorts of stuff.
Yeah.
We try to give you everything that you need to get started in research.
Yeah, I put both of the links in the chat, and the Research Academy is free for everybody. So you can sign up. It'll make it look like you're getting a membership, and that's just because that's how our website is set up, but it's free. So you just sign up, and then you'll get information about everything we're doing in the future. So feel free to sign up. Also up above, you will see that I put in our next Research Academy presentation, and I'll tell you about the next monthly webinar in a minute after the questions. But also we offer mentoring that's free through the end of this year for sure. And so we have one-to-one mentoring about just about anything research. And then we are also doing a 4-week series, 2 of them this year. One starts in a week on January 26th, and we already have people signed up. And that is if you want to publish a case study, or if you want to present a case study or a poster at a conference. And so those links are to our forums, and you can look at the forum and fill it out if you'd like and join us. All right, so what other questions do you have or comments for Bruce? I see thank yous, but I don't see any other questions. Okay.
Well, it must have been clear then.
Sounds like we've got a wrap.
It does. It does. So thank you so much for being here. And thank you, Bruce. Your presentations are always really informative and also really fun to listen to and to see. Next month on February 18th at 6:30 Mountain Time, Carol Scheidel, who's up here talking as well, and Nancy Lubin will be our webinar speakers presenting Latin Really? What's in a Name? And they'll explore the critical importance of using correct botanical nomenclature. So I think that'll be really interested. And in addition to the forum where we're asking you about topics, you can email education@alliance-aromatherapist.org anytime if you think of a speaker or a topic that interests you. We offer CEs for these presentations, and if you're a member, you go to the AIA website, answer the questions, and you will get that CE. For non-members, you would write to info@alliance-aromatherapist.org.
And for this presentation, the questions are not hard.
All right. Okay. Well, thank you so much again for joining us. We'll be here next month. Looking forward to bringing you more aromatic wisdom. If you're not a member, but you'd like to learn more, you can contact the membership committee with any questions that you have. And I'll put that in the chat as well. All right. Thanks again, Bruce. And thank you, everybody, for attending. That wraps up today's session. Thanks for tuning into the AIA Research Academy. This academy exists thanks to the generous support of the Gaffasi Foundation and is here to make aromatherapy research fun, accessible, and relevant. Our mission is simple yet powerful: to educate, inspire, and connect a global community committed to advancing the science of aromatherapy. We envision a future where research is not just part of the conversation, but the culture. The best part? Access is completely free. Simply sign up through the link in the description box below. And if you're an AIA member, the Academy is already part of your member benefits, putting powerful resources right at your fingertips. If you're passionate about deepening your understanding of aromatherapy through research, you're in the right place. Be sure to subscribe and hit the notification bell to stay connected with our latest sessions. We appreciate your curiosity, your time, and your commitment to learning.